So this is a quick tutorial on Jason's jump and how to complete the form. So the first part is what we did together in class for parts 1 through 7. So for part 1, we find the mass of Jason. So we have 130 pounds. And then in order to convert pounds into kilograms, you divide by 2.2. When we do 130 divided by 2.2, we get 59.1. So we'll just leave it at 59 kilograms. And then for question 2, we want to take this mass and figure out what the force is being applied to it. And so this can happen to any object with mass. As long as we use the weight equation, we can figure out what its force and weight is going to be. So we know that Jason is 59 kilograms. We always use the force of gravity, which is 10 meters per second per second. So weight times gravity will always give us the force that's acting on that object. And this happens for any object. So 59 times 10, and that will give us 590 for the force of Jason. And so any object, whatever it is, multiply that mass in kilograms by 10, and you figure out what the weight of it is. And weight is a force, so that's always represented by newtons. For part 3, we wanted to look at Jason's jump, which is shown here. We want to know what the maximum height is. So if we look at the graph, we can see that this is 0.6, this is 0.8, so he had to jump at 0.7. We want to figure out how much force is needed to get Jason to jump. So because of Newton's third law, we know that whatever Jason's force is, which is 590, we know that that equal and opposite force has to be applied in order for him to jump. So that means that this is also 590. Then we want to calculate the work done. In order to calculate work, it's force times distance. So you actually have to physically move an object a certain length or distance or height. And that's how we can figure out how much work has been done. So we already know what Jason's force is, which is 590. We know that the maximum height that he jumped was 0.7. So all we have to do is multiply 590 times 0.7, and we get 413. And this is energy. So work is energy, kinetic energy is energy, GPE, EPE, all of those are always going to be measured with joules. Okay, and then question 6 is trying to figure out what is the GPE. So kilograms, we know now, what is the GPE, when he's at 0.2. So we want to know when Jason is right here, what is his GPE when he's right here? Okay, so we know his kilograms, again, was 59. We know that his mass was 10, because of gravity. So mass times gravity times height, just like we did from the last section. So 59 times 10 times the height, which is 0.2. That's what we wanted to know. So then we will multiply all of those, 59 times 10, which is just his weight, right, which is 590, and then times that by 0.2, which is his height, we get 118 joules. So now that we have this information, we should be able to try and figure out what the conversion will be. So there's a couple of things that we need to know about this sheet. The first thing is total energy. If you remember from last time, section 8, when we looked at the skateboarder, the total energy always stayed the same. The graph never moved, which means total energy is always conserved. We cannot gain it, we cannot destroy it, we can only transform it. So if I have 413, then I will always have 413. So this is always, no matter what, throughout this entire jump in this system, is going to be 413. Because energy is always conserved. And that's what we call the law of conservation of energy. What we also know is a couple of other things. First of all, we know what we just calculated. We know at 0.2 that Jason's GPE is 118. So here's our GPE at 0.2. That's 118. We also know that at position 0, when Jason is just started and he's at the beginning of the jump, he's on the ground, Well, if he's on the ground, that means he doesn't have height, which means our GPE is 0. He also hasn't started, which means he doesn't have motion, which means our kinetic energy is 0. So if this is the case, if we know that his GPE at 0 is 0 and his KE at 0 is 0, the total energy is still 413 joules. What means is that that is all in the bend of the knees. That's all the elastic potential energy of 413. Now, once Jason's off the ground and he's at 0.2, well, now he doesn't have energy anymore. He doesn't have the elastic energy, because remember, elastic energy is if you're touching something and anything at all. And so if he's not touching the ground anymore and Jason is in the air, that means that he has 0 elastic potential energy, which also means throughout the entire jump, Jason has 0 elastic potential energy because he's not touching anything. So if this is the case, and I know that 118 is here, and I know that the total energy is 413, this plus this plus this must equal the total energy of 413. So all we have to do is subtract the total energy from the GPE that we calculated, which gives us 295. So then we can take this next part and we can calculate the GPE just like we did for this one and find the answer for this. And then when we subtract that from the total, we can figure out what the kinetic energy is. Because we don't have speed, so we can't use the kinetic energy equation, but we can still figure it out because of the law of conservation. And we will do that for each one of these sections. And then we also want to do that for just before he lands and hits the ground. So your job is to finish the rest of this. And then you also have some questions that are here for you to complete that are going to make sure you understand what's going on in the chart here. The very last thing you will do is your work problems. And so these are exactly like this one here, which is the calculating the amount of work. We know that work is measured in joules. That's our energy. We know that the force is always measured in our newtons. And then our mass is always going to be, our meters is always going to be our distance. And so I have the equation that's here, and this will be the same thing as work is equal to force times distance. And so your job is just to complete the rest of the problems here. Once you have done that, then all you have to do is go ahead and submit into It's Learning. Feel free to email me if you have any other questions about the page.